Welcome back to the calculus lecture series. In this video, we're going to be going over the product rule. Now, we looked at the power rule, which stated if we have some term of x, right, we can bring the power down and subtract the exponent by 1 and find the derivative. But in this video, I want to look at what's called the power rule, which is a similar kind of idea, right? A rule to help us find the derivative of something given a scenario. So the scenario we're given for the product rule is if f of x is equal to a term u times a term v. And those are just placeholder variables. There's no real meaning to u. It's just a term that we'll call u and a term that we will call v. So, for example, in example 1, we have 6x to the third times 7x to the fourth, right? That's an example of product rule, right? U times v. So then we can say that f prime of x, right, given this scenario, the product rule states that u prime, which is the derivative of u, times v plus v prime, the derivative of v, times u is equal to the value of the derivative. So let's just go ahead and do it. I think that's the best way to go about this here. So let's identify u and v respectively. So we say that u is some term. We'll call that, so we'll call u 6x to the third, right? Now let's find v. We'll say that 7x to the fourth is v, right? So notice how we set this up here. We're saying that it's u, 6x to the third, times v, 7x to the fourth. And that's true. That's exactly what product rule states. So now let's find the derivatives of our functions here. So of u, we just take the derivative, and let me grab a calculator for this math. I'm not good at my quick mental math. 6 times 3, we just do a simple power rule here. 18x to the second is the derivative of that. And then for v prime, 7 times 4, 28x to the third. Okay. So that's pretty simple there. Now let's go ahead and, oops, sorry, I didn't put my prime symbol for the u prime. So now that we have our terms, let's put it together in our f. We're saying that f prime of x is equal to this. So let's do that. 18x to the second. We're multiplying that by v, 7x to the fourth. We're going to add that to v prime of x, which is 28x to the third. And then we multiply that by u. And u in this case is 6x to the third. Okay, so we have our terms here set up. We can do a little bit of simplification. We can actually do distributive property and multiply the two together. So 18 times 7 is, and we're going to say that this is what f prime of x is equal to, 126x to the 6, right? When we multiply exponents, we add the exponent, or when we multiply two terms with exponents, we add the exponents. So 126x to the 6 is the product of that. The product of 28x to the third times 6x to the third is 168x to the 6, right? So we have like terms here. We can simply add them together, and we see that f prime of x is equal to 294x to the 6. And we can actually prove this here if we take these two terms and we multiply them together, right? So we multiply that, bring the product out. 6 times 7 is 42. X to the 7th. What's 42 times, right, this is f of x. Now f prime of x, 42 times 7, 294, x to the 6, right? We got the same thing we did here. In this case, we just distribute it, and it is easier in this case, but this is just to show you how the rule works, right? So pretty simple there. Let's move on to another example. We have in problem 2 the cube root of t times in a quantity parentheses 3t to the second plus 2. So in this example, we identify two terms here. We identify our u and our v. Okay, and I'm not going to worry about colors anymore. Hopefully you get the gist. Let's actually rewrite, make that more defined V, this more of a U, so you don't get confused. So we're saying that V is equal to t to the 1/3, right? Because we can write cube root as to the 3rd power, like the square root is to the 1/2 power. So V prime in this case, we bring the power down, so that's 1/3 t, and then we subtract it here. So 1/3 minus 1, that's negative 2/3. All right, and if you want to convert that there just for whatever reason, it would be 1/3 t to the 2nd. All right, but we're going to keep it as a fractional exponent here just to keep things simple. Makes things peachy keen jelly bean. Okay, so we're going to say that u here is equal to 3t squared plus 2. And therefore u prime, we bring down the 2, that makes it 6t, and the 2's a constant, so it disappears. Wow, this is quite a mouthful to be lecturing, but I do it because I love lecturing. F prime of x is equal to u prime times v. U prime is 6t, v is just t to the 1/3. We multiply those terms together, and then we're going to add that to v prime, which is 1/3 t to the negative 2/3, right? And then we're multiplying that by 3t squared plus 2. Okay, so we have our terms here. We can keep it as is if we'd like, and let me make sure that's allowed. We could distribute out. I think that would be fine. Yeah, sure, why not? Let's go ahead and distribute out. Let's do a little simplification here, because why not? We can distribute out our 6. F prime of x is equal to 6. Remember, we multiply exponents, we add them together. So this is 6t to the 4/3, right, for this here. So we have, yep. And then for this term here, where's my calculator at? 1/3 times 3, that's just 1t, and then we need to add the exponent. So negative 2/3 plus 2 is t to the 4/3. All right, we bring it out here to 2 times 1/3 is 2/3, t to the negative 2/3. So that is our derivative here. Notice it looks a little funky, but yeah, that's what the derivative is equal to. You would not feasibly be able to do that quickly with a power rule, right? Distributing a square root like that and getting it simple, not the easiest. It's probably easier just to do the product rule. And then we're going to end off with a nice easy problem. Thank the Lord Jesus Christ. Okay, so we'll call this u, this v. So u is equal to x squared plus 2x minus 5, and that makes u prime 2x plus 2. V, and I'm going to go a little quick through this. You can try it if you like. Sorry, I probably should have said that first. V is equal to x squared minus 2, making v prime 2x. So let's go ahead and solve here. And you can go out of order too. It doesn't have to be u prime times v first. It could be v prime times u first. Really doesn't matter because you're adding it. It's an additive term. If it was subtraction, that would be different. So I'll actually go in the opposite way here. 2x, which is v prime x squared plus 2x minus 5 plus x squared minus 2, 2x plus 2. Okay, so you can go ahead and simplify this. Let me make sure that you guys can actually see my work over here. Let me scooch y'all over. So yeah, let's find f prime of x now. So we're going to distribute the 2, so that's 2x to the third plus 4x squared minus 10x, quantity added to 2, and we're going to FOIL here, 2x to the third plus 2x squared minus 4x minus 4, okay? And then we can add these terms together. Holy crap, this is quite the mouthful. It's just more of a tedious question, if anything. Right at this point, I think you got it. So negative 14x minus 4 is equal to the derivative of our function. So that is the product rule. I'm sure right by now you're a master at this, but trust me, your professors, and I know every single one does this. They on your example sheets, they give you easy problems. You get to the test, they're fucking hard. So practice, practice, practice. Paul Math Notes online. CUDA software, great resources. I highly recommend it. Don't just trust these examples here to carry you through the test and give you a good score. You need to practice the harder problems. So you should be expected to know trig by now, but I will be posting a trig derivative video. Hope you guys enjoyed. Have a wonderful day.